Okay, so one question that's maybe popped into your head is, why are these special triangles? Why are these special triangles? So let me give you an example. Let's say we just have this right triangle, 4 and y, and we want to find the value of y. Well, we would start off with, that's not too bad, a squared plus b squared equals c squared. So we would have 4 squared plus, we run into a problem here. We don't know the length of this side. So when you have a right triangle and you want to find, for example, the hypotenuse or one of the sides, you need 2 of the other sides. However, notice that in our previous problems with the 45, 45, 90 or a 30, 60, 90, I only gave you the length of one side. And from the length of that one side, we were able to get the other 2 sides. And so that's what makes them special. In our special right triangle, if you know the length of one side, you can find the length of the other 2 sides. So for our special right triangles, if you are given the length of one side, you can find the length of the other 2 sides. So there you go. That's what makes them special. So in this particular case, in this problem here, because we don't have the length of this side here, we can't find the value of y. All right, so let's look at one more example. Let's look at this. If the sides of an equilateral triangle are each 2 1/2 inches, what is the area of the triangle? All right. Okay, so this is a good problem here. So let's go ahead and draw an equilateral triangle. And so this is 2 1/2, this is 2 1/2, and this is 2 1/2. All right, now we know in general, I'm going to write it over here, area is 1/2 the base times the height. Now we know the base is 2 1/2. What we don't have is the height. And so the height is the length of the altitude. So here's our altitude, and we want h. So how do we get the height? Well, what we do is we notice, and this is how we got the 30, 60, 90 triangle, but when we draw the height, we notice that this is a 30, 60, 90 triangle. Okay. So now normally I would associate this side with 2a, this side with a, and this side with a times the square root of 3. So because we have this 30, 60, 90 triangle, we can figure out what is the height. All right, so we know that 2a is 2 1/2. So we've got to divide each side by 2. So let's rewrite this. We have 2a is 5/2. So when you divide each side by 2, a is 5/4. Okay, so that's the length of this side. 5/4. So then that means h, which is a times the square root of 3, must be 5/4 times the square root of 3. Alright, so now we have the ability to find our area. It is 1/2, the base is 5/2, the height is 5 square root of 3/4. And so what do we end up with here? 5 times 5 is 25 times the square root of 3 over 16 inches squared. And there is the area of that triangle. Good. So in this video, we went over the second special right triangle, the 30, 60, 90. And the big thing with the 30, 60, 90 is if the length of the shortest leg is A, then the length of the hypotenuse is twice that, and the length of the longer leg is A times the square root of 3, essentially. And we did a couple of examples of using that, and we also talked about why the 45, 45, 90 and the 30, 60, 90 are special triangles. And essentially, if you are given the length of one side, you can find the length of the other two sides.